Hey.
Sorry.
Good.
Well, welcome everybody to Dallas Programmable Robotics Group, Robot Builders Night Virtual for November 4th, 2025. Tonight, we'll go through our regular presentation, roboticists, and then after that, we'll open up the floor to any questions or comments or stump the club, whatever you want to do. So first off, we have Mike going to give us an update on his robot. He's having a problem with ROS2 and GPS.
Okay. All right. So basically, last time I tried to do a demo, I was having technical difficulties. So this time, I'm just going to show so I've been working on getting the robot to work with a compass and to work and have a potential to work with GPS, and fusing all that data together using ROS2. And so I was using the recommendation of two localizers, one for the it's one for the local data, which is basically it generates the, well, in ROS2 there's the map frame, which is the base frame, or the frame, the center, the base, the lowest frame, and then there's a odom frame, and then there's the base link frame, which is the where your actual robot is, and so there's a transform between the frames, and so like typically using like a map-based ROS implementation for localization, the AMCL generates the transform between the map and the odom frame, and that's to counter drift in the odometry. And then there is a robot localizer node that's provided by the navigation package that see, I think I have this information. Hold on a second. Let me pull up the drawing. Where is that darn thing? I think I put it in my okay. So I'm going to share this screen here. Share, select the window, select this guy. Now, then go to my GitHub site, and so this is the sort of a recommendation of how it's pretty small. I wonder how I can blow it up some. It doesn't like to blow up. Okay. It just makes all kinds of weird stuff. Okay, so basically, there's a extended Kalman filter, which is the local, which creates the odom to base translation. And so basically, if your odometry is perfect, the odometry is the same as map. If there's no drift, if there's no errors in it, and so so basically this global EFK is not needed if you're not trying to compensate for any kind of odometry drift. And then using the GPS type setup, you have two extended Kalman filters. One's for the local, which is the ODOM to base transformation, and then there's another one which is global, which goes from map to ODOM. And in AMC, in a typical ROS2 localization solution, the AMCL package does this transform. And so I've been trying to get these things to work without causing errors, and I've done a good job. I think I've done a good job of that. And then there's the NavSat transform node package, or node from the robot localization nav stuff. And it takes your GPS and fuses it with all this other stuff and does a transformation into the map frame. Now that's my big question. I don't understand how that all works, but that's going to be this starting tomorrow. I'm going to try to really work on that. And so now I'm going to. So this is sort of how my new nodes are working. Like the wheel odometry feeds in, and the IMU feeds into both of those, but the GPS only feeds into the global, which is basically trying to be your localization that AMCL typically does. Okay, so I'm going to stop this share, and I'm going to share a ROS bag that I've been working on. And so let me show the whole screen here. So right. So can everybody see the screen?
Yes.
Am I doing well?
Absolutely.
Hello?
So far, so good.
Can you hear us, Mike?
I can't hear. What's going on here? Oh, what did I do? Oh, I muted the speaker. I'm sorry.
Can you hear us now?
Okay, I can hear people now. Okay.
Carry on. You're doing great.
Okay. I just couldn't hear anything, but I hit a tab and hit the speaker on a tab and turned the speaker off on that. Okay, so now if I go to the so this is the screen. This is the Foxglove screen. And so on here I have like the battery voltage. You can see my battery's getting low during my running, and there's no satellites in view, which is the SIV window here. And the calibration says it's at good calibration. It sort of lies a lot. And then the compass data is this one here. And this is my map view. And so you can see the I'm gonna just let it run, and yeah, so when I started up my simulation, you can see the line running across here. The first thing it does is I do a dance to attempt to get the IMU calibrated, and then after that, then I align the map to the actual orientation, and then I do a little slower dance to find the cone, and then it found the cone and backed up, and then that's basically what I was doing. I'm running in 5x mode. So if I look at this, if I blow this one up and adjust this, okay, this is my cone right here showing up with the laser scanner, and the few little dots that you might be able to see is my time of flight, my big array of time of flight sensor, and so they're both showing the cone right here, and so when I Come on. There it is. So I'm dancing around, and then it magically sees the cone and goes, "Ooh, I know what the cone is," and it starts to go towards it. And then you can see this this long little shape here, and that's the planned path. That's what the navigator software is planning. And so it says, okay, I see a cone, I give a location, and it says, okay, get close to the cone. Don't get too close because, well, just don't get too close. and then it switches over to you can see that little blob freezes, so it's not getting updated anymore, but it doesn't disappear. And then you can see that now I'm running my own software using the cone, the cone detection, using the camera, and then I switch over to the Lidar cone detection, and because that gives me much better control. I send command velocity messages using my own software instead of having the navigator do it. And so you can see that it's approaching it, and then it kisses it right there, and then backs off. And you can see right here, see if I can zoom in on this a little. So you can start to see the shape of the cone when I got close to it. So this is the cone, but since the cone has a shape to it, this is further away from the robot than my time of flight sensors, which see the cone lower down. And so I'm using the time of flight sensors to know when I touch the cone, because I'm touching the bottom of the cone, not the top of the cone. And so you can see that and then once I do it, and then I back up. Any questions about this little show and tell?
So are you doing this by XY coordinate or by GPS?
XY. I haven't figured out the GPS and how it interacts with the navigator yet. I'm still trying to figure that out. And so this is just inside the house, and I have let me show you my file. Okay, well, I have a file that has the coordinates I'm going to, and this is basically, the cone is basically about 2 meters away. So I say, okay, go 2 meters, and then start searching for the cone. So right here, it's looking, yeah. So basically it went here, but it's not, well, wait a second. Okay, so at this point, it says, go 2 meters away. And the cone's not there. I took it away so it wouldn't see it until I wanted it to. And so basically, and stop 1 meter before you get there, because I don't want to run over. I just want to get close to the cone. So you can see that that's 2 meters here, so it stops at about 1 meter. And then it says, okay, I'm close to the cone. The cone's supposed to be at this coordinate, and it's just a meter coordinate. So it's like 0, 2, which is 0 and 2 meters. And then I start doing a dance, which is basically running a circle, but instead of running it as a circle, I'm running it as a dance thing, because it gives me a tighter radius. I just go forward, backwards, turning the wheels each time. And then at this point, it says, oh, I see the cone. So it doesn't see the cone until here. It says, oh, I see the cone. And then it starts going towards the cone. And then it switches over to manual control. Not me manual control, but my custom software instead of using the navigator package. And so if I run it, so this is running it. Okay, this is my startup. Just having a while. The software is starting up, And you notice that the field is pointed the wrong direction because I haven't set the pose yet. And so it's calibrating the IMU, and then it switches, says, okay, I'm going to set my pose, and it moved towards the cone. It's not very far because I'm in my house. and then it does a little dance to try to find the cone, and then it finds it and backs up. So that's where I'm at right now. And so I have some, like, this screen here is the linear velocity screen, and this screen here is the angular velocity screen, and this screen here is there's an angular and a linear velocity overlapping on each other. This is the compass information screen, and this is my cone detection screen. So if I bring this one up, you can see that it's running around, and then it finally sees the cone, and it starts to approach it. And then when it gets close enough to it, then it switches over to manual mode, and then at this point here is where it actually touches the cone. And then at this point here, I back up from the cone. And so the bottom line here is the Y coordinate, which means when it's 0, it's pointing directly at the cone. And this purple line here is the distance, for the cone distance. And so it's basically does a little oscillation here, a little unstable. I think that's in the Navigator software. And then once I pass it over, then everything stabilizes pretty nice, and it pulls in smoothly, and then it says, okay, I've touched the cone, done. And then it backs up, and then it gets another waypoint and moves to it, but the waypoint is basically where it's at, so it doesn't move hardly at all. So this is interesting here, because this is my cone detection. You can see it here, so it has some noise in the cone detection, and all of a sudden it gets good solid cone detection. I have some filters to filter out all that noise, and then it goes, oh, I got it. and then it pulls in, and then does the final pull in, and then backing up is just backing up, and the cone goes further out. So, and then if I look at this screen here, and this is my linear velocity, which is basically the wheel velocity, and so you can see at this point here, I'm just doing a fast movement to try to get the IMU calibrated, and the input is the green dots up here, which is my command velocity, which is basically the command given to the wheel controller. And then this is the speed of the actual wheel, the drive shaft sensor that says, okay, it's ramping up to the right speed, and then it switches off, and then it does it again, but it's changing direction. So you can see that it's going forwards, backwards, forwards, backwards, forwards, backwards, and then it says, okay, I've done it. I do a little bit of manual adjustment to get it right back to the origin again. So manual control with the game controller. And then I hit the button that says, okay, start the navigation, and then the navigation starts to do a slower version of that, where it searches while it's trying to detect a cone. So it's just doing that little dance back and forth, rotating, and then it detected the cone and then pulled in, and then did a big backup right there. And so this screen here is the rotational velocity. Always rotate in the same direction. I probably need to randomize that, but rotate in the same direction. And so it's going forwards and then backwards, while with the same rotation angle, rate of rotation, and then it just goes down. If I look at this screen here, I sort of overlaid the linear and the angular velocity of the output of my EFK filter, my extended Kalman filter, that fuse the two together for linear and angular velocity. And so now I'm getting both of them together. So you can see that the purple line there is the angular velocity, and the orange line is the linear velocity. So everything's running really good. It took me a while to get these things settled down. I found a couple problems in my configuration where it was drifting off and just not aligning well. But everything's working pretty good. I still don't understand that, like the 1 second delay between linear and angular. Linear is coming from the wheel encoders and angular is coming from the IMU. But it seems to work okay, even though there's a delay. Maybe it's real. I'm not sure where the delay is coming from. And then this is the something that so I'm basically plotting the quaternion Z and W, which is basically gives you some angles, and so that's for that noise down in here, just to see what's going on. And I'm looking at both the local and the global outputs of both filters, and they're overlaying perfectly right now because there's no drift. And then this one here that goes up and down is the actual compass setting. So this is like the input to the compass setting, and then I convert that to actual yaw and plot that out. So that's the blue line that goes up and down. And the top line up there is my calibration. So it's staying calibrated at 3 and then dips to 1, 2, and then goes to 3 and dips to 2 and goes to 3. So it sort of tries to stay in calibration just by moving around. And so on this screen here, if I do the so I'm starting from scratch, and then you can see that like this is the compass right here. So when it's pointing this way, it's okay. This is like okay, but yeah. So you can see it's just jumping around. So these are just interesting things to see. So these are my debug stuff, and this is where I'm at. And now I got to figure out how to run it with GPS data instead of just with GPS coordinates instead of XY coordinates, so that I can actually use GPS as the localization. So that's basically my show and tell.
Have some questions for Mike.
Yeah.
Yeah, I got a question. Which version you have an RP Lidar on it?
Yeah.
Yeah. Which version is it? Do you know?
It's the S3, which is basically outdoor rated for high ambient light, and it's sealed up to the elements. Yeah.
And the other question was, how much did you pay for it? So $600 or something?
No, it's like 200 or something. But yeah.
Really? Oh, I was looking them up on the S2s and S3s on AliExpress, and they were, like in the $4 to $6 range, depending on.
I don't remember spending that much on it. I bought it a year or so ago, or a year and a half ago.
That's why.
Yep.
You don't have the ×2 factor.
Yeah, right.
Maybe that's it.
Yeah.
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 But
Look
Yeah.
like they're pretty pricey.
Yeah, but the interesting thing is one of the interesting things is on this, when I'm moving around and get close to that cone, yeah, you can see the little dots. I probably should make them bigger. Little dots are my time of flight sensors, so it's seeing the cone here, and it can see the table and the legs, and just there's obstacles over there, so it's supposed to avoid that. And it does a good job of avoiding it when I'm trying to travel through the corridor. It sees the Lidar and it sees all this stuff and just stays away from the noise. Yeah. So that's that I can't remember the VL53L8, I think, sensor, which is supposed to be, again, a higher ambient light sensor.
Yeah, better for outdoors. Yeah.
A little more expensive than the L5s, which is all of them are like my sensors here. I have 3 of them, so it gives me about 130 degree. Each of them has 45 degree, and so I put them all together, and I got a 130 degree range. You can sort of see it. So you can see. Can you see these little specks on the screen?
Yep.
Yeah.
So that's the specs here are it's seeing the floor, and so you can see the range of the sensor. And when I compute that into a point cloud, it's basically these are at zero meters above the floor, and I ignore any of these points below 100, like 100 centimeters or 100 millimeters, 10 centimeters, just so that I don't count those as obstacles to avoid. So I'm not trying to avoid the floor. So,
Mike, you said you bought your S3 about a year ago, and you thought it was about $200.
yeah.
Yeah, I want to say that was mine too. So, hey, Pat.
Yeah.
Can you, from a Canadian website, can you look up the S3, the RP Lidar S3 from Canada, and see? I'm thinking it might be tariffs is the why that's $500.
Yeah.
S3M.
It's RP Lidar S3.
Okay, where can I find it?
RoboShop probably has it.
Okay, I'm going to go to the Robot Shop, Canada.
Okay. And so I'll yap while he's doing that. And so I've been enjoying using Foxglove for this ability to have all these plots so that I can actually see what's going on, and I can play back a ROS bag to sort of see what's going on to make sure everything's fine. Like I can do this in real time and watch it, but then it goes away. But using a ROS bag, I can inspect it and make sure that everything is, all the sensor values are as I expect. So can't wait to bring it outside where my satellite's in view. Like about right here is like 10 satellites, which is where it starts to work good. And when it's below 6 satellites, I just block the GPS data because it's completely unreliable.
Okay, so that's not it, huh? I wonder why it was so cheap a year ago. Because like I said, I think I got one. I haven't used it, but I bought one because I said, wow, this is cool. Because of I think it's guaranteed like to 100K lux.
Yeah.
Yeah, here's one on AliExpress. It's $804
Whoa.
for an S3.
Yeah. Well,
So,
I found the same thing at 970 or 790 Canadian on AliExpress and $712 on Robot Shop Canada.
yeah. I wonder why it jumped up so high. Oh well.
I know. I wouldn't buy it today, but
Yeah.
I'm glad I bought it.
Yeah, same here. So Mike, it looks like you really got this nailed. It looks really cool. Now, if I understand you, you're using right now. You're using the just the local Kalman filter. That's what all this is, right?
I'm using basically I'm using both filters, but the global filter is not having any errors. It's not drifting with.
Okay.
There's no. It's not correcting for the drift because it doesn't have the data to correct for the drift.
Okay, because it didn't have the.
But I'm running the whole package right now with just no GPS data, and like a week ago it was drifting all over the place, and I stopped looking at the acceleration from the IMU, and the drift stopped happening. So
Yeah. Okay.
so it stopped integrating the acceleration in.
Yeah. This really looks neat.
Yeah.
I can't wait to see it when you do it.
I can't either. Yeah. So I gotta crack the GPS nut because I don't want to just hack it. I've been thinking of ways I could hack it, but I'm going to try to really do it the way you're quote unquote supposed to do it, using the GPS coordinates and feeding them directly into the navigation package. But I just haven't wrapped my brain around it. I haven't figured it out yet. I might run one of the simulation packages that does that and just try to figure out what's going on. I just can't find any good tutorials or anything that explains it clearly to me.
Yeah. Well, probably what you need to do is take the robot outside and run it so that you have the GPS signal, and then do your bag and find out what the difference between the two filters is showing. You know.
Yeah. I was thinking even if I just do XY coordinates, the GPS. I don't know. Should do the
Well, you
localization.
remember Dave Anderson when he first started out, he was just using odometry.
Right.
Okay. Otherwise, he had equivalent to your local Kalman filter, and he was successful. So you know.
Yeah. So I could just do that and see what happens if I can't figure out GPS by the end of the month. So.
I was gonna say you're gonna be ready by the 22nd, or
To me?
no, Mike.
Oh, Mike, I think will be. Yeah, you should.
I'll have something running. It'll be like the pure odometry, or hopefully I have GPS to keep it localized so it doesn't drift all over the place. Yeah.
I didn't mention that, but there's
once it sees a
just over
cone,
2.5.
it does a great job, but getting it close to a cone is the hard part. Yeah. Like
Well, looking forward to your next question, Mike.
Yeah. Because I want to take it back outside and use my sensors and my software I have right now, which I've fixed a lot of the drift and error problems, and see if I can detect cones outside just using odometry, and not make it too hard, And I think I can do it and get it close enough to see the cone, because I have to be like 10 meters away from a cone to see it with my camera to detect a cone. Actually, it's about 8 meters, but yeah, so it has to be relatively close.
Question: how much are you depending on the network to keep you going?
No, I'm not using RTK.
Everything is local on the robot.
Right.
So because that's usually the one that when people have tried to use ROS in the past, they're depending on some sort of weird Wi-Fi setup, and it just doesn't. It's not reliable enough.
Yeah. So basically, I have the router on the robot, but I'm assuming that's only for initializing it and getting it into the starting position, to getting it to start, and then it can run off and lose connection to to the internet and to the computer and everything, and it's storing the ROS bag locally on the SSD. So I'm going to be storing all that information so I can see what happens. So, why did it fail? Yeah.
Yeah. This would be great.
Wouldn't that
Yeah.
Wi-Fi thing be against the rules if it actually depended upon it? Right?
I'm sorry?
It's supposed to, wouldn't the Wi-Fi thing causing a problem with the ROS be against the rules because it's not autonomous onto itself? It's depending on something else to
If
give
you
it
read the
information?
rules, you're right, Harold. That's right. But in the past, I think we've allowed Paul to kind of bend that a little bit. But
I get monitoring and all that other kind of things, but if it actually depended upon it, that would probably be a problem, right?
yeah, because I really think, what we're trying to emulate, I think, in these is, a self-contained unit that finds the cones, not something that's, got the whole world web backing it up. And,
Yeah. Like, I think the thing is, in the RTK situations, you can use Wi-Fi for the RTK localization, or you can use a cell phone or something.
yeah.
I think Paul was just using Wi-Fi as his RTK signal.
Okay. Yeah. And I know I've got it set up
For his
here.
correction.
Yeah.
Correction.
Get the corrections from, mine is from a radio, and I think, Scott, yours is from a radio too, isn't it?
Yeah.
It'll be
So-
interesting. We have all these radios out there. What's gonna? We'll probably find out that we're all on channel 10 or something. We'll see how it all goes.
Yeah, so it'll be interesting to see what happens. I've noticed that my visual code, when I'm running it remotely to my robot, it doesn't come up unless I have an internet connection, because it's downloading some code every time into VS Code. So I will be connecting to the house Wi-Fi internet to get my VS Code up and running and to get it started. But once it's started, it's not going to use it. So
Something that, well, I'll wait until I get a chance. Go ahead. Sorry to interrupt.
oh, I'm fine. Yeah, I'm excited because last week I was getting depressed and now it's sort of started working again. I thought I killed it or something, and so I'm happy now. I can see the end of the tunnel.
That's some good progress, Mike. I don't know if that qualifies for a black star or not.
Oh yeah, definitely.
I don't know how we record those things, Doug, for black star.
Well, when I'm here, I try to keep track of it. So yeah, definitely a black star. Good.
Yeah,
I thought it was a gold star.
Huh?
I thought it was a gold star.
A gold star, if he ran it on the ground, we have real definition of what a gold star is.
I see.
But essentially what a black star is that there has been significant progress. Okay.
Yeah.
We probably don't give as many black stars as we should, but that presentation definitely needs a black star.
Yeah, I'd get a gold star if I showed it moving.
Well, exactly.
But the last time I tried to do that, I just failed completely, technically. So
Yeah. So, okay.
Any other questions for Mike? Hey, hurry up. Work on your bots. Only got 2.5 weeks. Next up, we have bot.
All right. So, I'm not sure if it'll qualify for a black star or gold star, but so this was some testing. It was actually 2 weeks ago. This is using RTK. Now I did not remap the cones here, so you'll see it's kind of going a little to the left of the cone. But about that right there where it starts to slow down, it sees the cone. And right now I've got it set up kind of where it pauses right there. And now that it's locked onto the cone, it's gonna go and kiss it.
Nice
It sort of looks
touch.
like mine. That's sort of like what mine does. It goes and then it slows down. Yeah.
Yeah.
And
As
backs
long
up.
as it gets centered up on the cone really well, you know, if it has to kind of rotate at the last minute, sometimes it can really be aggressive, let's call it. But you know, it travels at a pretty good clip. So I mean, I'm willing to, what is it, a 10-second penalty, I think, if you knock the ball off the top. So, and again, you know, this is pretty much dead on it. And you were talking about, you know, integrating your GPS information, Mike. Originally, I would actually calculate the X and Y coordinates for a particular GPS. And then everything was based on, you know, a Cartesian plane, you know, X, Y navigation. And I found that to be somewhat problematic and error prone because of you're doing all the calculations and conversions back and forth. And then David Anderson actually published some math functions to do the calculation for basically heading and distance to a cone. And that seems to work much better, you know, as far as accumulated errors in your calculations and that sort of thing. So, like I said, I think I mentioned last time I was showing some videos that I've been working on the obstacle avoidance. So I started inside my shop here so that it couldn't just go straight to the cone. So this is kind of its obstacle avoidance routine as it's walking its way down the wall. And so now it's finally made it out and is on its way to the cone. And you'll see here, I'll pan over, and I've got some obstacles set up in the yard here for it to have to navigate through. And this is one of the situations where it kind of has to rotate into the cone at the last minute. And you'll see it kind of push the cone over a little bit. That's something
that might have knocked it off. It's still pretty gentle.
Yeah, and you know, I could try to sit around and play with it, but I decided, you know, that I'm happy with this behavior. So I've kind of stopped, you know, trying to improve it, quote unquote.
Yeah.
Because it seems to be working pretty well. I don't want to screw something up. So right now, really, I'm just kind of working on getting Turd up to this kind of, because I have RTK that I built into Turd as well, because, you know, I have all of the infrastructure for it. So it kind of made sense just to add it to Turd as well. In this particular run, it kind of hit right between those two obstacles. I've got another video here where it has to go around multiple ones, and of course there it got a little close, but it still found the cone when it got back.
It looks
And here's
formidable.
another example of kind of hitting it from the side. But you know, it completed the course, right?
Good. Looks really good.
So this is another run where it has a little bit more of a obstacle it has to avoid. Or no, I guess it's the next video. And I also want to get the obstacle avoidance a little smoother where, you know, pauses and then turns and pauses and turns. I'd like to see that a little bit smoother, but again, I think that's improvements for maybe next year. So I think this last one, it has a little bit more obstacle, yeah. Where it's got to avoid that guy, and then it's like, oh no, there's something over there too.
That's impressive how it singles out that one cone and not the one inside the garage.
Well, you know, Mike just mentioned something about, you know, have to be close enough to the cone. So the way the logic works is once I'm close enough to the GPS coordinate I was supposed to go to, whatever cone's got to also be within, I think it's about 3 or 4 feet. It's a variable that I can adjust based on, you know, conditions. And I think it's set at about 50 inches at the moment. So it kind of does single that out, because one of the concerns I have just lining up on a cone based on distance readings is, you know, what if it's not really a cone, right? So there is that kind of that risk. Although I was able to get the Pixie Cam working on this on Belch, so you know, if it works, and typically when the Pixie Cams work, they work really well most of the time. Except for it seems like on the last cone for the last couple of years.
Yeah, you know what? That last cone is cursed or something.
Yeah, and so at least when it comes to this robot, it is. It seems like, but so now I actually have, now that I've got the Pixie Cam working, now I have 2 methods to detect the cone. It can be an either or. I didn't set it up where it had to be an and. You know, a Pixie image and, you know, line up on it. So hopefully I've got a better chance of finding the last cone this year. But you know, like I said, I'm pretty happy with the way it's performing right now. And you know, it also, again, you know, I don't know if it's really the Beagle Bone or anything else, but it seems very stable. You know, in years past, I had a lot of problems with software crashing and, you know, it just doing stuff that it wasn't supposed to do. So, you know, and all the time I've spent upgrading it this year, it's been really positive experience as far as, you know, having it do what it's supposed to do. So, and now the software, I just keep refining and refining. I hadn't rewritten it at all. And I found a few more bugs, a couple of segmentation fault things where I was overrunning buffers at certain times, or could have. So, like I said, it's gotten to be fairly stable. So, hopefully, you know, my only goal this year is to get a perfect score, because, you know, the last time I got a perfect score was, 5 or 6 years ago. And I started upgrading from there, and I hadn't got a perfect score since. So, but, and like you saw the obstacle avoidance. So I might, you know, if I complete the course, I might try it, you know, without any kind of alternate waypoints to go around the house, or, you know, whatever obstacles are in there. So, and like I said, right now I'm just trying to get turret up to the same basic spot, because it's basically got the same resources. You know, I put a new RTK antenna on it, new radio, so it's got the same XB radio infrastructure. And Doug, you were talking about, you know, we all have different radios. Well, I have what I call the master hub, and it's got Ford radios in it, because I have an RTK station that talks to the main hub, and then I have 2 radios, one that talks to Belch and one that talks to Turd. So they're there'll be a bunch of radios out there, but you know, hopefully these XBs can handle that. I guess we'll find out.
Yeah.
Although, the XPs have like a 32-bit signature, and you basically, because I've got mine set up to point, so you have to basically put the radio A's serial number into radio B, and then vice versa. So that's the only thing they'll talk to. And I know these XPs do frequency hopping. I think there's 30 something bands that they'll hop. So hopefully, I don't know, I guess we'll see.
Yeah, we'll see.
I've been really impressed with the XPs though. I was using some older Link. There's a company called Link, LINX, and I think that XP bought them out because they're not around anymore. But I actually had to have software in the serial routines to say, okay, well, is this an error? Or, is this, because I had to validate every packet, and I would routinely drop bytes and, drop data. Plus they were locked at 57.6, 57,000 baud. So, you could only get so high, and the XPs I think will go up to like 200K. I think they will. I've got mine running at 115, and they don't even struggle. So I actually took the code out, just to see, my checksum algorithm and whatnot, and it's pretty solid. So
Scott, which are you using, a rotating lidar or the TF Mini S's on a servo, or how are you doing
for Belch? No, I just have 3 of the Mini S's. Now the 2 outside ones, you can't really see it in the picture, although I've stopped sharing my screen. They're actually on servos, so I can rotate them in and out because, we talked about it, I guess, several weeks ago. They've got a very narrow cone, right? I think the cone's only about 3 degrees. So I kind of try to offset that by, having the ability to rotate them around. But as you've seen, you've got plenty of field of vision. You don't really have much of a dead spot in there, because I played with that, backing away from the cone and rotating around and seeing if there was a dead spot and what the angles should be. So, what I'll do is once I get a hit on a cone, I actually rotate them in a little bit. And then when I'm, navigating and using them for obstacle avoidance, then I'll rotate them out some so I have a little bit wider field of view. But realistically, anything outside your wheel well or wheel, distance, you don't care about anyway. I mean, I can drive right by something as long as I don't have to run over it, right? Or hit it. They've been, really impressed with those little sensors. They're really nice. I wish they had some sort of addressing scheme on them though, because each one has to have its own serial port. I think you can get a CAN version as well that you can set, the addressing on them, but the ones I have on there are just serial. But you can set them up where you just power them up and it just starts puking data out at you. So the interface is really not that bad. So that's, I don't know if that's a black star or gold star, Doug.
That's gold star. You got one.
That's my progress, and that's what you chumps are up against in a couple of weeks.
Mm-hmm.
Throw the gauntlet down right now. That's
right. I'll just start the trash talking now. I mean, I've already scared Paul into vacation. He's not even going to be there. He just doesn't want to have to give up his throne, I don't think. But
he's as close to leaving the planet as you can. He's got scared, eh? He's gone a long way. Good
Yeah,
stuff.
he brought that up in the last meeting. He thought he had the best score you could get, but with just 3 waypoints, you can get 10 points.
I think the max is 11 now.
Yeah, I
Isn't
think
it,
it's
Doug?
11. I think so. Yeah.
It is 11? Oh,
Yeah.
well, okay. If
If
you don't use
you-
GPS at
let's
all or
see.
something.
Yeah, no
I think if
GPS.
you use the published coordinates and don't measure your own,
Yeah.
and then only use those waypoints, I think it is.
Yeah, that's what I'm shooting for. Yeah.
Yeah.
So that gets you 12 or 11, you said, huh?
Yeah. Now we still call 9 a perfect score, but you can get more perfect if you want to think of it. Otherwise,
Bonus.
after you get a perfect score, now you're going after the challenges. Yeah.
Yeah, because I'm
And,
using just the regular GPS. So as long as I get within 5 or 6 meters, then I can search with the camera and find it. So
yeah.
What are you doing? Object recognition with the camera, Mike?
yeah, yes. And then that pulls me in to a meter or so, and then I switch over to detecting it with the lidar, the cone, because the camera sort of poops out. But I'm looking at the plots, and the camera isn't pooping out, but I've seen it poop out when it gets close. So I stop using it when I get really close. It sort of has nearsightedness. And
Well, yeah, even with the Pixie cams, right? I mean, it starts filling up the screen, and you
Right.
can't, then you don't know where the center of it is.
right. So when I get within a half a meter or something like that, then I switch over to my time of flight sensors and my lidar to know where the center of the cone is more accurately.
Yeah, and that's what I do on CanMan as well.
Yeah.
I use that same kind of approach, but you only get so close with the camera.
Yeah. But if I can get to 6 or 8 meters, the camera works good, and then I can pull it into a half a meter and then start using lidar and stuff to approach the cone. Yeah.
You can actually go to a wider angle lens, and it makes everything smaller. So you can't make it so wide angle that the cone or the can that's 10 feet away is not recognizable, but
yeah,
that's a trick you can do too.
Yeah, just today I was testing it, and it was my first test of the cone detection while I was searching for it, and it would sort of point at it, and right when it got to the edge of the screen, it would say there's a cone. But then when I tried to switch when I tried to go to the cone, it sort of would move a little bit and be off, and it sort of oscillate. So I made it sort of say has to be in the center of the screen, not on the edge of the screen. So it has to be more aligned before it says, "Hey, the cone's in front of me," instead of just anywhere in the 120 degrees or whatever I have on my camera.
Mm-hmm. Yeah, Kareem had another suggestion: put the camera at the back of the robot, overlooking everything. Yeah, so that's another thing you can do is just back the camera up a little.
That's a really good idea.
Yeah.
It also gets rid of your dead space. Most of these things, like you said, up close, they can't handle it.
Yeah.
Well, that's impressive. 2 good robot presentations tonight. Making some progress.
Yeah. So one of them's going to do it. I'm hoping mine does a honorable mention, or at least doesn't fall into the lake or anything. Yeah.
That would not be good.
Yeah,
At least get you a nice coffee cup.
and my first thing this year is get a mug, and then after that get some points. But I first want to get that mug.
Mhm.
Okay. Pat, is it me?
If you've got something to present, you're up next.
Yeah, well, okay, I had 2 things. One thing is, I don't know if everybody got this, but there were Thomas Messerschmidt sent out last week an invitation to visit the AI SIG discussion group that is done by Homebrew Robotics. Did everybody get that last week?
I saw that on the list.
Okay, yeah. Well, I actually went in there for a small period of time, and I did learn something really pretty simple, but it's and I know some of our members probably do it, but if you don't know about this, I thought I'd show it to you real quick. And that is, if you're, let me see if I can share this. Okay, I'm going to share the entire screen. Okay, share. All right. Okay, all right. So if you're in, this is a Visual Studio Code, and if you've been using OpenAI, Chat GPT, it's giving you a bunch of code, and you can take that and you can copy paste it. But they have this coding agent here called Codex, where it just puts it right into the program. So you set a directory and put your files in that directory, and then you use this. Then you can essentially type in a prompt, and when you have that prompt, then it will do whatever the prompt tells you to do, and it will change the code, I think, interactively. But it also has some sort of Git agent in it, so that you can roll them back if you want to. So anyway, but the first trick is if you type in Codex, you'll notice that there's a bunch of codexes. The one you want is the one that's got the OpenAI logo. You don't want these other ones, unless and you can see Claude 4 is down there and a few others, but this is the one for OpenAI. So anyway, that was something that's pretty easy to do, and I was doing it in a much more convoluted way. And so this is kind of an improvement for me. I thought I'd just share that with you. It also, the meeting itself is actually pretty interesting. So I'm going to stop sharing that and going to see if it'll let me do this. Oh. My camera's turned off. Oh, wait a minute. Maybe I have to do a camera turned on. Okay. How do I pin myself? Can you guys do a pin? Just pin me so you can see what I'm going to do. Okay, thank you. This is what you get for $22. Comes in a little box. We don't need the box anymore. And if I can get this thing, come on, where is it? Yeah, there we go. Okay, so you get all of these little goodies here. And this is a way to get a ST micro array, 8x8 array, with a very easy way to do. The interface is really simple. You can make it UART, you can make it I2C. I think you can even go SPI, but I'm not sure. And the real trick to this, the difference between this and the Pololu module, is this microprocessor that's right here. It actually has an M1 or an M0. I'm not sure which one. So it takes all of the coding pretty much out of it. You just you ask for the data and you get an array of 68 bits. And it also has the advantage that, I don't know if we can zoom in on this. Oh, well, okay, somewhere in here, there's some jumpers. So you can set the I2C address. I think they have 3 bits. So what is that? Eight positions. So you could have 8 of these guys running, and this costs $22. Now, the difference between this and the sensor Mike is using the latest sensor this is, I think that's a L7, Mike, isn't that right?
You're muted, Mike.
I'm using the L8.
L8. Well, this is the one that's you used to use.
Right, L5 is what I
This is the
use.
L5. So it has a little less range, and it's not quite as outdoor robust, supposedly. But anyway, kind of an interesting sensor, very nicely priced, because it's the. So this is 22, and I want to say that the Pololu module with this chip on it is 24. So it's actually a little bit cheaper than the Pololu one. And, you know, I just order them straight from DFRobot, and there wasn't any funky weirdness to it. It just came in. So, and it has this little bracket here that goes up here, so you don't have to go worry about mounting and all of that stuff. And it's even got a couple of standoffs, bunches of screws. And it's got let's see, just I'm not sure what it's in it, and the 4-position JST, and I'm just looking at it, and I'd say it's either it's probably 2 millimeter. I'm just guessing. So pretty easy to even connect up.
So the USB connector on it, that's for configuring the microcontroller on it?
I think so. Yeah.
Okay. Mhm.
Yeah, you can, and power too, I guess, Mike. You might be able to power it through that. I don't think you have to power it through that, but
Yeah.
otherwise, let me put it this way. If you're using this on your, just to see if it works on your computer, you know, it's easier to just plug the USB in,
Mhm.
you know, but if you're doing it with a microcontroller on a robot, then you want to use the I2C bus, which is on this side.
Yeah, so having 4 pins is probably supplies power too.
Yeah, it supplies.
Well, is that one of the Grove connectors, Doug?
Could be.
I
it kinda looks like
want
it.
to say Grove is seed something. I can't remember. It's the one that has SEED something or other.
Well, like you said, it's, you know, a JST series.
Yeah, it's
connector.
JST, but it's. I mean, I'm pretty sure it's 2 millimeter. So nothing. It's not. Doesn't look bizarre, Scott. You know, Groves can be a little tricky because the original Grove Grove connector had some funky wings on it and a few other things. You can stick a JST 2 millimeter into it, I believe, or 2.54 maybe, into probably a 2.54 into it, but you know, it's not as, you know, I try to kind of stay away from Grove if I can, but I'm not opposed to using it. It's just that I don't, you know, I have to just get more different types of wires. Anyway, let's see. Those were the 2 big points I wanted to share. So anyway, if you're coding and you might want to check out that thing when I think he's, like you said, I believe it's in the Discord.
It has a 60-degree field of vision.
Yeah. Yeah, this one is a little, I think with the 8, I think they'd reduced the field of view from 60 to, what is it? Isn't it a little less?
Depends, is field of vision like X and Y, or is it like diagonal?
No, there's 90-degree
be
diagonal.
diagonal.
It's
Okay.
90-degree diagonal.
Okay, yeah, because
Yeah.
the sensors I'm using have 45-degree and the X and the Y direction. So
Yeah. And this one uses 60, I think.
yeah, so
I
3 of
don't know
them
about-
gives you.
I don't know it's vertical though. You know.
Yeah, so 3 of them will give you the 180. So that's pretty good.
Yeah. Well, like I say, they definitely. I'm like I say, if you're using it indoors, I think this is the way to go. It's just a lot simpler.
Mhm.
It's cheaper and it's simpler. Okay. And I don't know if they're ever they may update it to an 8 someday, and if they do, because it wouldn't be much hard for them to do an 8. Then we'll see how that goes. A little more expensive, but
Does it use the sensor from ST Micro or?
yeah,
Okay,
yeah. It's
they can drop that one in. Yeah.
yeah. So anyway, I think that's kind of cool, and I thought it would be worth looking at because I think Mike has shown that this is a valuable alternative to things like ultrasonic. It's faster. It's pretty robust, and so anyway, it's just a better sensor. We live in cool times, guys. The toys just keep coming, so it's hard to keep up. So, and I guess the third thing is those of you who have been part of the what is it, M5, M6 version of the newest Kickstarter camera thing. I don't know. Do you remember that, Ray? What's the one you use? OpenMV? No.
Oh yeah, I haven't looked at that in a while. I think mine are
anyway,
getting a little dated.
They're saying the OpenMV cameras they've sent them off to get built, so we'll see how that's coming for that Kickstarter. If you guys I don't know if you took part in it, but
No.
I bought one of them. We'll see how it goes.
Okay. Yeah, my robot, I'm using the Oak D Lite.
Yeah, I still think that's a good choice. But I really do like the PulseLite too. If you're not using it for distance, like you're using it for distance,
Yeah,
you're using
yes.
the depth camera. But if you're not
Right.
using the depth camera, the PulseLite is definitely a good camera. It uses the same software, and it's 4 megaflops or whatever it is, which seems to be good enough. So anyway, you can unpin me now.
Yeah, I've got you unpinned already. I believe I posted the link for that sensor in the chat.
Okay.
I think that was the one from DFRobot.
Yeah.
And I don't know if you want to post I don't know if that OpenMV camera is still available. If you want to post that in the chat as well.
Well, like I say, it was a Kickstarter, which I don't know it's obviously been kickstarted, so I can't I don't know if it's going to be available until later in the year.
Yeah, I heard that I saw an advertisement from OpenMV that it runs YOLO 8.
Yeah.
On the new camera that's coming out.
Yeah. And I want to say they're compared to the other guys, they're really I want to say they're like 13 megateraflops or whatever. Or whatever. So they're going to be they're way faster than you need, for our robots.
Yeah.
So.
Yeah, I think that the Max Cam supported YOLO 8 too.
Yeah. Well, Mike, you can use YOLO on the you can use YOLO on the what we were talking about.
Yeah, my Cone Slayer uses YOLO 3 or 4 or something.
Yeah.
On the OP.
Around with one of those, and I want to say I think it was 11, and it's okay, but I honestly didn't see a whole lot of improvement over what I was using before. No, I don't know. I think the advantage of the YOLO is that you can go on processors that aren't as good. You know what I mean? You don't need as much.
Mm-hmm. Yeah, because I get about 30 or 40 frames per second
Yeah.
cone detection. So
I forget what the max cam gave me, but I think I was using YOLO V5 on it.
I think so. But,
And I was getting a decent frame rate, like good enough for cone detection, definitely.
Mhm.
Yep. Let's see. I'm hoping to be out there with you guys.
So I'm looking forward to watching.
Still struggling.
mhm.
All right.
Thanks, Doug.
Okay.
That was the end of our presenters. I don't think there's anyone else on the list. Does anyone have anything to discuss or share?
Yeah, I do. It's something to show. I was going to use my phone. It's going to work. Try to do it. Join here too. Oop, did I show up there? Sir?
Is that your new robot on the ceiling?
No. Oh, I don't know if you can see it. I got
Oh.
echo.
There it is.
Let's see. I got to mute one of these.
Your robot looks like a ceiling fan.
That's what I thought. A hexapod.
It's
Oh,
got great
the
localization
big bright spot is the
capability.
Death Star.
It's a pentapod. There's a science experiment. Ray, I think you got both your microphones muted.
Okay. Okay, can you hear me?
Yeah.
Yes.
Okay. Anyway, so this is a board with a cutie pie and a little display that Seed Studio makes. And I've got it's an old PulseLite version 2. And it's sitting just taped on a battery pack. And this was the quick and dirty approach to obstacle avoidance. I just asked Copilot, I said, okay, provide me with an optical avoidance scheme that uses the PulseLite and the processor. So what it's doing, it's showing what what the scan is on the display, and it's either saying F for forward, R for right, L for left, or stop if there is no forward option.
Can you zoom in a little on the display, because we really can't see it too well.
Oh, okay. Let me see if I can.
Okay, I get it. Yeah.
And that's moving it around. I'm just pointing it at the wall. Anyway,
Nice.
in the left-hand corner there, did you see the R and the F?
Yeah.
Come up.
Looks like an F, but
Forward. So basically it divides, there's three 30-degree zones. 30 degrees facing forward, 30 degrees to the left of that, and then 30 degrees to the right of forward. And so it looks at all three zones and sees if there's an obstacle in it. And if there is, I think I wiggled some wires here. I might hit the reset. And it's still hooked. Okay. Yank the power. There you go. Yeah, now it's working again. This is not the most stable setup. Anyway, so it was pretty quick. I didn't have to think too much about what kind of scheme to use. Copilot pretty much provided that. I think it might
There's
be
some horrible feedback going on.
Oh, okay. I'll get out of the phone.
So Ray, I missed it. What is the sensor that's being rotated?
Oh, it's a. Oh, I'm still on. Hold on, let me clear that out. Okay, did that get rid of the feedback? Good.
Yep.
Sounds like it did. It's a PulseLite version 2, circa maybe 2015.
That's LiDAR, also known as LiDAR light.
Yeah. Yep. Anyway, PulseLite was the company that initially made it, and then it was bought out by Garmin. They still sell something like that. I think
Yeah,
it's like version 4 now.
Yeah, they changed the name to LiDAR light, I think.
Yeah.
Garmin LiDAR light.
Yeah. Anyway, it did really well outside. Supposedly you could go 40 meters with it.
Whoa.
And so I thought for shorter distances, I wanted to see how it did. I actually had another setup with the 5X on it. Just on everything is done in a cardboard box or on a cardboard box. So this one is actually the spark front sensor, and same sort of thing. I had a little display. I don't even know if you can make that out. Right there. Just showing all 64 readings in different colors, so I could figure out which line those sensors were basically from. Does okay inside. Outside it gets kind of washed out in sunlight, but it is this one is the 5CX. So I haven't tested. I have a 7 and an 8. I haven't tested those to see how they'll do, but I'm thinking that might be a better option than the PulseLite, because it is slow. Basically, what it does is you pick the distance that the scan is wide enough so that you can get through a path, or you have a path to go forward or to go left or to go right. And since my robot is like 18 inches wide, I just said, okay, I want my path to be 20 inches wide and 5 feet away. And so if it could, it could see in the 3 zones, if there's a clear path in one of them, left, right, or forward, it would actually go to that point. Or you would let it go to that point just based on whether it told you to go forward or told you to go left or told you to go right. So I still have a little bit of time to do better obstacle avoidance than just my 2 switches in the front of the robot, which don't work very well. I actually lowered the bumper in the front, and I was thinking that would work better, but the way it actuates the switch, it really limits the amount of travel, and it seems like it needs just a little bit more time to slow down and stop before it reaches the end of the travel of the switch. So but I have another scheme, a third scheme. So it's like the Ackley's rule of 3. Takes 3 tries to get it right. So hopefully it's not going to be Ray's law of 4. So anyway, That's all I had. So I just been kind of experimenting.
So Ray, how is your gate? Is it working well?
It is. It
Good.
opens, it closes. So,
Yeah.
and occasionally it stops midway, and I have no reason why it does that, but
Mhm.
it's a lot easier to, especially when it's cold and it's rainy. You don't have to stop and open the gate. It's kind of nice. So it is. It seems like everything out here is susceptible to lightning. The first opener got hit by lightning. Whenever lightning strikes anywhere near the house, things just go crazy. And so I'm not certain why that is, but
Yeah. I guess the long power cable cords and stuff, power lines just pick it all up. Yeah.
I don't know. Yeah, that's it's kind of scary if it is that. We've had several blown fuses on the transformer.
Mhm.
So I don't know. It's don't walk outside with a pointy metal helmet on, I guess, But anyway, so yeah, hopefully I'll get this all together. And it always, I was never, really didn't have enough time to develop obstacle avoidance. So I tried just using the bumper, and it failed miserably. So hopefully one of these other approaches is going to work much better. So, but and my third try at kind of just changing how the bumper does work, or how it actuates the switches. I think that'll be better, in a better position. So that's all I had.
Well, thanks, Ray. That was interesting. Cool demo with the little OLED display.
Yeah, we actually had it was something Doug and I worked on with the Nito lidars that came from is it James Leroy or LaCroix? I forget.
Leroy, oh, of course. Yeah, his website is surreal.com. Yeah,
Yeah,
can't think of his name right now.
yeah. I thought it was James Leroy or James LaCroix.
Yeah, yeah.
Anyway, we had a kind of a setup where it would put it on a displays that had 8-bit parallel inputs, and so you could write to them pretty fast, and even did distance circles, and really got kind of elaborate with it. And I don't think either of us did anything after it with that.
So many better lidars came around about that time. It was just, they're great for making a display where you don't care, just let it run and done. But to use it on a robot, I think there's better lidars.
Yeah,
Some of these ones that I think Paul and well, I don't know. I haven't actually used one, but I know that Paul and people making the little robots, Paul and Mark, they're starting to play with lidars now. Robots.
Yeah.
So lidars are making our hobby robots now without too much trouble.
Yep. Yeah. Anyway, it had like a little round belt on it,
Yeah.
and the belt disintegrated. It just fell apart in 6 or 7 pieces. So I actually went, and I didn't realize this, but you can get all different sizes of rubber bands. And so I replaced the little belt with, I think it's a size 19 rubber band. Works really well. So if you look at yours and it's laying there in pieces in the box that that you have it in, that's Yeah, I've
Or
got a.
you can buy replacement belts on Amazon too.
I had a hard time. I actually bought some belts that I thought that went with it, and they were not right. And they were cheap, so it wasn't great loss or anything. But it's like, trying to find out which belt the thing actually took, it seems impossible. So, but a lot of them claim to be for Nitos, but I don't know which model they came out of. They list several different model numbers, and apparently it wasn't the one that I picked. So
I have a whole stash of parts that weren't the right ones that I picked.
yeah.
I have a question I'd like to ask the group, just because I haven't done this in a while. Has anybody had a PCB made from JCL PCB recently, like in the last 2 months or so? Has anybody done that?
Yep, I've had several different versions made for different boards from them.
How has the tariffs made them a lot more expensive, or are they about the same? Scott?
I'm trying to remember. It wasn't a significant increase. It's hard to say because different size boards and whatnot. But the one batch, actually UPS dinged me for about $45 in tariffs.
Jeez.
And I don't, the shipping has gone up, and that I think where the tariffs are being collected at.
Right.
But no, it's still so damn cheap getting them from them. The tariffs aren't that big of an issue.
Did you have yours shipped to you through the DSL, or or did you just let them come slow boat?
No, well, they have a couple of, they want to do what is it, the European one,
DHL, I think.
DHL, thank you, Ray. And I don't know what goes on in their handling facility in Cincinnati, but I had a stencil got hung up there for 2.5 weeks. I got the boards and no stencil. And I kept, asking them what's going on. So it's a little bit extra to get UPS to deliver them. UPS has like a global something or other, and it's about, $7, $8, $10 more in shipping. But man, I got the last batch I got almost like within a week.
Okay.
Actually delivered to the door. So I haven't had any real problems from them.
So you're buying the board with the stencil, but you're not getting them populated, right?
Correct.
Okay.
Yeah, I have a stencil printer and a reflow oven. So yeah, I just bake my own. I make a lot of prototype board stuff for work, so I do a lot of that professionally as well. When we're prototyping a board or designing something new, that's usually where the first batch comes from, as I hand build them. So between that and the robots, I give them a bunch of business.
Okay, well, that's good to know, because I've been kind of a little bit afraid of buying anything from China lately, because I've heard these horror stories about where the guy gets, $200 tariff charge or something like that. And, I don't want to have anything. Let me ask you this, Scott. When you make your order, do you know how much it's going to cost you?
Yep.
And they don't, so it doesn't go up. You don't get any weird surprise.
Well, the one time that I got dinged by UPS, that one I didn't expect. But the orders since then, and that was, I think when they were trying to figure out the whole tariff thing, that was probably 6 months ago. The ones here recently, and I'm talking as recently as probably about 3 weeks ago, You know, shipping was, I mean, you pay as much for shipping as you do the boards and the stencil. You know, but it's still, you know, typically it's still less than like $200 for, you know, half a dozen prototype boards, you know, of reasonable size. And the stencils are like $18. So it's almost like you can't not get one.
Yeah. Okay. Well, that's good. I mean, I'm encouraged then. Yeah. I don't have anything.
Now the thing I will say about JLC is their website really kind of sucks. Because you upload your Gerbers to it, and then they kind of analyze your Gerbers and start filling in the board size, and you know, and then you fill out, you know, what kind of finish you want and that sort of thing. And I had it's a very odd shaped board because it fits inside an enclosure, so it had a lot of curves and cutouts in it, and every time I loaded the Gerbers to it, it thought it was a 10 by 10 board. Because it just couldn't handle all of the geometry of the shape. And I even emailed, I was going back and forth with them, and they said, well, our tech department is working on that. You know, can you try it now? Oh, can you try it now? And I ended up going to, what's the other one? I just went to their website, PCB Way, imported the Gerbers, and it said, oh yeah, you know, and it showed me a picture of the actual shape of the board. So I just went through them, and they weren't bad. You know, as far as cost goes, they weren't bad either.
Of the two, which one you still would prefer, JCL?
Yeah.
It's cheaper. Yeah. Okay. That's what
I guess we're lucky we don't live in Honolulu. There was a UPS plane that crashed in.
No, that they were going to Honolulu. They crashed in
Louisville.
Kentucky.
Yeah.
Louisville, yeah.
Yeah. Yeah, that's what I'm saying. Yeah. Good thing we don't live in Hawaii.
Yeah. Good thing I wasn't shipping anything to Hawaii, you know.
Yeah. Yeah.
I'm just curious. Has anybody seen anything, any PCB makers in the United States that are even, you know, remotely even within the same magnitude of these, you know, JCL?
Yeah.
Okay. I haven't found it either. Okay.
I think your labor market is in a different range.
Yeah, I know.
Well, PCB Way is one of the U.S. based companies, but they outsource everything to Asia. So usually they're quite a bit more than, you know, the JCL or I think I said PCB Way earlier, but that's not right. There's another one, or JLC, and then there's where is that? I don't know. The JLC, other than their website, and maybe they've got it fixed now. And if you just got a square board, it does fine. But that's really the only knock I can give against them. I've had really good luck out of them.
Well, I've to JCL in the past, you know, I've made round boards, I've made boards with weird shapes and stuff, and you know, they've always been able to handle it. You must have been really doing something strange.
It was it had a lot of contours to it, but they should have been able to handle it. So
anyway, okay, that was one of the questions I wanted to ask. Yeah, I've been kind of like afraid to order anything from China. I know, Ray, you used to do a lot of AliExpress. How's that? Are you still buying stuff from AliExpress without any trouble?
Yeah, I haven't bought anything though recently. Probably not within the last 2 months or so.
Okay.
But yeah, I'm gonna open my own Tanner's electronics store here. No.
Yeah.
Yeah. I was on a buying spree there for a while.
Mhm.
I know here in Canada, when I order AliExpress, I've been ordering lately choice products. And they're showing up within 2 weeks.
So you're not having any problem up in Canada.
No, we're not throwing any bricks through windows or anything. We're
What is Canada's tariff rules with China do? You guys?
there's limitations per package, like anything else. You've got a daily limit, you've got through the mail a package limit, that sort of thing.
Okay.
A few years ago it was quite low, like $40, and you could be susceptible to tariffs.
Yeah.
Like maybe 5 years ago, but they raised that up to quite a bit. I think it might be closer to $80, 80 or 200 now, I forget.
Yeah.
And then most of the stuff we order, is $10, $20 things, a display, a chip, a sensor, or whatever.
Mhm.
So it's not bad.
Mhm.
And then the other one that I deal a lot with, because we don't have a Tanner's, or I know you guys used to, or a Micro Center or anything, but it's Amazon as well.
Yeah, that's true. Yeah, I picked up some really nice ESP modules from WaveShare from Amazon.
Yeah. If I don't want to wait for the slow boat from China, a couple weeks or whatever, I'll order from Amazon, and it's here in a couple days.
Yeah.
Their overnight delivery takes 3 days here,
Mhm.
but it's still not bad. And like you say, you order the ESP processors, or what else? A WaveShare RP.
Yeah.
RP 2040 that sort of thing, and it's working. I ordered you guys were talking about Lidar earlier off of Amazon. It's RP Lidar C1.
C1.
Yeah, C1. So it's 10 hertz indoors. It's on CanBot. So I've got him mounted, and it's almost ready to start rolling. I've got the RP, the WaveShare RP 2040 0 on the bottom, with a couple boards on top, a motor driver on top, and then a proto board on top of that to get my encoders in there. And just been working away on that, getting it ready. But that's not for this fall's competition. That's for this spring's competition.
Yeah. Yeah.
I want to try to have something ready, and I decided to concentrate on just the one.
Mhm.
Well, you can use the claws to grab the cone and try to move it outside. Yeah.
I had a comment about Scott. It's an excellent video Scott made in his backyard, I'm assuming. I'm wondering if Steve is going to have the grass cut that nicely for you guys this year.
Well, supposedly he's got a really nice automated robot mower, which he wants to show off to us. And he says, he runs like every day, cutting different parts of his yard. So, it's something in use all the time. So it'll be interesting to see. This is a really nice one, like in the $6,000 or $7,000 range type.
Oh, wow.
So I'm kind of excited to see that too. We'll see.
And the grass still grows in November in Texas. So,
Yeah. It's ready to be snowed on here. So
Yeah. Yeah.
anyone else have a robot related topic or question?
Nope.
Are we going to call it a night?
Sounds good.
Great
All right.
presentation tonight, guys.
Yeah.
all right. I'll see you next week.
Okay, everybody.